Welcome back to Rice.AI Code Room. Today we are tackling LeetCode 1663, detect cycles in 2D grid. In this problem, we are given a 2D grid of characters. We need to determine if there exists any cycle consisting of the same character value. A cycle is a path of length 4 or more that starts and ends at the same cell, moving only horizontally or vertically to adjacent cells with the same value. Importantly, you cannot move to the cell that you visited in your immediately preceding move. Let's clarify the constraints. The grid size is up to 500 by 500, which means the total number of cells can be 250,000. This tells us we need a solution with O of m times n time complexity to run efficiently within the time limit. A depth-first search or breadth-first search approach is ideal here. For our thought process, we can view the grid as a graph where each cell connects to its neighbors of the same character. We can use depth-first search to detect cycles. As we explore the grid, we mark each cell as visited and keep track of its parent cell, which is the cell we just came from. If we encounter a cell that has already been visited, and it is not the parent cell, it means we have found a cycle. We will repeat this search from every unvisited cell. Let's dive into the C++ implementation. We initialize a 2D Boolean array to keep track of visited cells. We then iterate through every cell in the grid. If a cell has not been visited, we start our DFS from that cell, passing -1 as the parent coordinates. If the DFS finds a cycle, we immediately return true. Next, let's look at the recursive DFS function. We mark the current cell as visited. Then, we iterate through the 4 possible directions. For each valid adjacent cell that has the same character, we check if it is already visited. If it is unvisited, we recursively call DFS on it. If it is already visited, and its coordinates are not equal to our parent coordinates, it means we have closed a cycle, so we return true. Finally, let's review the complexity analysis. The time complexity is O of m times n, where m and n are the dimensions of the grid. This is because every cell is visited at most once during the DFS traversal. The space complexity is also O of m times n, due to the recursion stack and the visited matrix. Thank you for watching.